Carl, who is here today from the University of North Carolina, where he taught pharmacology, is going to be singing about. Let's give Will a warm welcome and pick us up.
Thank you. Despite my age, I actually did not know Pythagoras. I guess, can we have the proof here? Don't leave. This proof proceeds by what's called a reductio ad absurdum. That is, you assume something is true, you reason, and you reach a contradiction. And since logic can never produce a contradiction from correct assumptions, your assumption must be wrong. So Pythagoras assumed that the square root of 2 is rational, which basically meant that the square root of 2 is p over q, where p is some integer and q is some integer. And he assumed also that there's no common factor. If there's a common factor, like each of these is 3 times something, cancel out the 3 in the numerator and denominator. So this is in lowest terms, as we say. And so if you square both sides of this equation, you get 2 is p squared divided by q squared, which implies that p squared is 2 times q squared. So p is an even number. Okay? And if you play around with just a little bit more, it's very easy to see that q is an even number. Contradiction. We assumed that they had no factor in common. Suddenly we said, hey, they're both multiples of 2. Contradiction. Therefore, there is no p in q, which is equal to the square root of 2. Now, there is one slight flaw in this proof. It has never been set to music. Until now. If you take a right triangle with sides A and B and C, then A squared summed with B squared equals C squared, don't you see? If A and B have unit length when squared and summed, it's true. That third side simply has to be that strange square root of 2. Oh, triangle, what problems you let loose. If you are right, there's something wrong with the hypotenuse. What is the length of that third side? Oh, how I wish I knew. It is a number that when squared becomes precisely 2. We write your value equal to a p that's over q. So p squared over q squared must exactly equal to. Oh, triangle, what problems you let loose. If you are right, then something's wrong with the hypotenuse. If p and q are integers, we write in lowest terms. A reduction to absurdity, the paradox confirms. For you can see that p is even, so indeed is q. So they can't be in lowest terms, which we assumed was true. Oh, triangle, what problems you let loose. If you are right, there's something wrong with the hypotenuse. So the length of the hypotenuse is irrational, you see, which drove Pythagoras to drink and sort of bothers me. Oh, triangle, what problems you let loose. If you are right, there's something wrong. There's something very, very wrong. And I've tried to tell you in this song, which has probably gone on much too long, with the hypotenuse.